Open the books. So how many questions I have given as a homework? 5 questions. Completed? Everyone? Check చేయొచ్చా books ని ఇప్పుడు? I'll check. Write on the topic spring force. So as we have discussed about what is spring force in the first class now, today we will discuss about how to do the problem of the spring forces. Okay. So what is the formula we have discussed? Like Fs is directly proportional to the delta x. Yes, no? Like change in length, either it can be elongation or compression. So it is directly proportional to the force whatever we have applied on the spring. So Fs will be equals to Kx. This is the formula. Take down. So what is the unit of the spring constant? Newton per meter. So try to remember only the formula, and if k increases, what about x, or x decreases, what about k? Okay. So listen here. So there is a spring and a block has been attached here, right now. So I need to find the force. How to find the force? How to draw the free body diagram first? Tell. Mg downwards, and then like whatever the thing we have discussed in the tension, no, the same thing. So tension will be towards upward. So what about the spring force? Again it is upward. What about the mg? Is there any doubt here? Is there any doubt? So can I say that Fs will be equals to mg? Yes or no? I have kept the object, obviously the elongation will be there. Yes, no? After elongation, again it will go down or what? It will go down. Yes or no? ఇప్పుడు ఒక ఆబ్జెక్ట్ ఉంది, లైక్ ఒక రోప్ ఉంది, ఓకేనా, లేదా ఒక స్ప్రింగ్ పెట్టుకుంటా, ఒక వెయిట్ అప్లోడ్ చేస్తాను, దాంట్లో ఏమవుతుందంటే ఇట్ విల్ ట్రై టు గో డౌన్. ఎస్ నో? సో ఆఫ్టర్ ది మ్యాక్సిమం లిమిట్ విల్ అగైన్ ఇట్ విల్ గో డౌన్. మ్యాక్సిమం వెళ్ళిపోయింది, తర్వాత వెళ్తున్నది అది? నో, it won't go up or it won't go down. Yes, no? So I can say that there will be some elongation also, that is delta x after keeping the block. So try to understand here, there is a spring, that's it. Second thing what I have done is I have added a block here. So what happened here? It will elongate. Now you understood, no? It will elongate. So I need to find what is the spring force also, I need to find what is the elongation also here. Two unknowns are there. How to find now? So that is the question. Try to listen here. So we know that after elongation it becomes rest, no? The body will become rest, which means there is no acceleration. Can I say that Fs minus mg will be equals to 0? Equals to ma, no? Yes or no? Equals to ma. When acceleration is 0, I can say that Fs is equals to mg. So what is mg here? What is m? 5 into 10. So spring force will be 15 Newton. Correct, na? 15 Newton. So when I talk about spring force I have, and I talk about spring constant also I have, then I can find the delta x. So Fs will be equals to k into x. This is 50 and this is 100, which is equals to x. So x will be equals to 0.5. 1 by 2 only, no? 0.5. Both are same. Take it. So this is how you will proceed the problems of the spring. Okay? Similar to tension only. Try to draw the spring force opposite of the given mg. Okay? Then take the problem. So any doubts here, or should I explain once again? Any doubts? Yes, no? So first I need to find what is the spring force and what is the acceleration of the block. Two blocks. Okay. Try to understand here. First let me take the block for one which is attached with the spring and the rope. So this is my mg. Spring force will be upward. Is there any doubt? What about the tension? Downward, no? Yes or no? Tension will be always opposite side of the given block, right? Yes, no? And the second one having the same mg and tension will be upward, correct? Now can I say T will be equals to mg? T will be equals to mg and Fs will be equals to mg plus T. Any doubt here? Any doubt? So it will be 2 mg. 2 mg. I kept the blocks. The block is at rest now. That's why I have taken T is equals to mg, F is equals to mg plus T. Okay, no? There is no acceleration here. Initially there is no acceleration. Now I am cutting this object. So at what acceleration this block will go? A person is jumping from the building. At what acceleration he will go down? 9.8 meter per second square. That is gravity. Yes, no? Can I say that this block is going with g? Yes or no? And what about this block? It's going upward. Minus g. Minus g. Think. 0 అంటే అక్కడే కదా ఉంటుంది, ఎందుకు పైన వెళ్తుంది? Any doubt up to this point? Any doubt up to this point? So first I have taken the block, I have taken the free body diagrams and I have equated the equations. I got T is equals to mg, Fs is equals to 2 mg. Now the thing is I have cutted the rope here. So what happened? It will be free fall, no? It will be in a free fall, na? Free fall means object will go with whatever gravity, like acceleration due to gravity, no? So this one can I say g will be equals to a? Yes, no? Is there any doubt up to this? Take down. I will talk about the acceleration of the spring now. Acceleration due to the rope is going down. So what about this one? It's going upward, no? Yes or no? If I cut this one, it will go down, it will go up. So can I say Fs is in this direction, mg in this direction and acceleration in this direction? Fs minus mg will be equals to ma. according to the equation whatever we have discussed yesterday? Yes, no? What is Fs here? 2 mg should be equals to ma, m and m will get cancelled, a will be equals to 2 g. Getting the point? I will explain once again, listen carefully. See, okay, so it will be g. Okay, so listen here. So I have taken a spring first, attached a block here, so it will elongate. Now it is at rest. Again I have tied a rope here, again I kept a one more block, so everything is at rest now, equilibrium condition. Okay, now what is the thing is, I need to analyze what are the forces are acting here. So when I analyze it, like one is spring force, one is tension, and one is mg. Second one is tension is there and mg is there. So I told that everything is in equilibrium condition, which means I can equate the conditions here. So this is positive and this is negative, and this is positive and this is negative, so should be equal, no? So Fs should be equals to T plus mg and T will be equals to mg. So I can take the T and I can substitute here, so I will get Fs is equals to 2 mg. So when I cut this rope, this block will go in free falling motion, which is nothing but with the gravity it will go. Okay, and this block will go in opposite direction. I need to find that acceleration. When I know the acceleration direction, that side I can take that as a positive force and opposite side negative force. So Fs minus mg will be equals to ma, and where mg is nothing but, sorry, Fs nothing but 2 mg. So 2 mg minus mg will give mg, which is equals to ma, and mm will get cancelled, a is equals to g. I will give one more problem here. This is mg, okay, this m I will take, or 2m, and this one is 5m. I need to find this acceleration and this acceleration now. Can you find it now? First, you won't get the same acceleration for the upward direction. Downward you can get it a only. Whatever it can be, mass, you will get a acceleration due to gravity only when object is in free falling motion. But what about the spring force acceleration? Use the same condition. First try to draw the free body diagram for both conditions. So it is in equilibrium condition, and then try to cut the rope. It will go with a free falling motion. I will say that this is acceleration is equals to g only, but I need this acceleration in terms of g now. Listen here. So free body diagram for mass 2m. So one will be 2 mg, no, downward 2 mg, and tension is there downward, that is T, and this is Fs. Second block which is having 5m, tension will be upward, it is 5 mg. So can I say the equation T is equals to 5 mg and F will be equals to 2 mg plus 5 mg, which is nothing but 7 mg. So I got the spring force here. So now if I cut this rope, it will go with a free falling body, right now, free falling motion. So free falling motion, I told that object can be any mass. If it is 0.1 gram also, or it can be 1 ton also, it will go with same acceleration g. Okay. Now this is my spring force, this is my 2 mg, and acceleration is upward. So F minus 2 mg will be equals to 2 times m into a. Whatever the mass, I have taken the mass. Mass is 2m, no? So 2m into acceleration. This is 7 mg minus 2 mg will be equals to 2m a. 5 mg will be equals to 2m a. M and m will get cancelled. A will be equals to 5g by, this is the acceleration. What happened, madam? Sure, what you have done? Fs is 7 mg got, okay. ఇక్కడ 2 mg రాసినావు కదా, మళ్ళీ ఎందుకు ఇక్కడ mg రాసినావు? తర్వాత ఇక్కడ ఇది 2ma కదా. Whatever the mass is there, no, that mass you should take directly, don't take m only. What happened? Huh? Correct only, no? What happened? You're not getting. అట్లా చెప్తేనే కదా అర్థమవుతుంది. So page number 40, question number 13, 13. Page number 40, question number 13. So M1 is given as 3 kg and M2 is given as 5 kg. Okay. So now it is attached with a rope. So acceleration of the system of two bodies over the wedge as shown in the given figure. I need to find the acceleration here. Okay. I need to find the acceleration. So first try to assume which direction I should take the acceleration here. Where I need to take? This side. If it is going downward, what about this one? Any doubt here? So this is my mg, no? That is 3g. Always downwards, no? And this is my 5g. This is my normal for this, no? And this is my normal for this one, no? Yes, no? There will be tension in the opposite direction of the mass, no? This is rope, na? There will be a tension. Any doubt here? Now I need to find the components. So what is the component of the first one, second one? Okay. This is 3g cos theta and this is 3g sin theta. So ఒకటి గుర్తుపెట్టుకోండి, ఎప్పుడైనా లైక్ ఈ ఇంక్లైన్డ్ మీద వచ్చేటప్పుడు sin theta, ఇది cos theta అవుతుంది. ఓకే, సేమ్ సిమిలర్ దిస్ ఆల్సో 5g, ఓకేనా, 5g sin theta and this one will be 5g cos theta. Any doubt here? Any doubt? ఎవరికైనా డౌట్స్ ఉందా ఇంకా? Or I should explain once again this one? Okay. Okay. So they have given the question that there is a block, two blocks inclined at an angle 30 degree and 60 degree. Okay. So one is of 5 kg and one is of 3 kg. So obviously we know that we'll try to assume that object will go in the direction of the 5 kg. Yes, no, towards down. When this is going towards down, this one will go upward. So this is acceleration direction. Up to this point it's clear, no? Now I need to talk about the components. So if I talk about the forces whatever acting on the 3 kg, one is normal force and one will be mg. Mg will be always acting towards down, but normal force perpendicular to the surface. So this is also a normal force which is perpendicular to the surface, and 5g will be acting towards down. Okay, we know that n is always not equals to the weight. Yes, no, the normal force is not always equals to the weight, that is mg. In this cases I can say this is normal force and this is my mg, so n will be equals to mg. But in this kind of cases I can't say, no, normal force and weight are not equal, no. So I should take the components. So when you are taking the components, like try to remember always this one will be cos theta and this one will be sin theta. Similarly this is cos theta and this is sin theta. Any doubt? Now whatever things are there, acceleration is there, tension is there, force is there. In this direction object is moving, no? Can I say that 5g sin theta minus t will be equals to 5a? This is the one force, no? Mass into acceleration. Now I'll add everything. This one will get cancelled off. 5g sin theta, no? Okay. Okay. Total it is. Before that, try to substitute the angles. This is sin 30, no? This is 60 should come here, and here 30 should come. Okay. Substitute the angle and then subtract it, because both are different angles, no? Yes or no? Both are different angles. Try to substitute the angles here. So 5g sin 60 minus 3g sin 30 should be equals to 80. Okay. So any doubt in taking the components and substituting the values now? Calculation you leave it. Any doubts in again? Any doubts on the inka? If you are having any doubts, you can raise your hands. I'll come there and I'll explain it. If you are feeling shy. So if we are talking about a same rope, tension will be equal. So in this case, what it is means, like it is going upward direction. So which means I should take tension as a positive. Opposite direction. So next topic is pseudo force. So pseudo force is nothing but it's a false force. Okay. So for example, listen here. Listen first. There is a block M, upon that I am having another block which is having mass small m. Okay, so this is on the ground. Okay, try to understand the conditions whatever I am saying here. There is a block M, capital M, and another block small m is there. Okay, a person is standing here on the ground, another person is standing on the block M. So this together going with acceleration a. Okay, together it's going with acceleration a. So person standing here, like let me take, I am standing here or some person is standing here and is observing the person and the block small m, okay, which is going with acceleration a or not. With respect to the person on the ground, this everything is going with acceleration a, yes or no? A person who is standing here and watching this block, what about the acceleration? What about the acceleration? A. It is 0. With respect to person on the block, A will be equals to 0. A person on the ground, A will, acceleration will be A only. Any doubt here? For example, I have told in the first class, a person, like two persons are sitting in the bus and a person standing outside and watching the persons inside. So bus is going with some acceleration. So I can say that the two persons are going with some acceleration, no? But when I talk about both persons are watching each other in the bus, what about those persons? They are in the same position, no? Yes or no? They are in the same position. They are not changing the position with respect to each other, no? Which means acceleration will be equals to 0. Correct, no? Same thing I will talk. There is a lift. A person is standing inside the lift. A block is there. So a person is standing outside the lift and watching. This lift is going with acceleration a here. Okay, a here. So can I draw the free body diagram for this block? Let me take this block as m. So it will be normal force. This one will be mg. So when acceleration is acting, n minus mg will be equals to na. Say ma. Any doubt? This equation is respect to this person, no? Yes or no? But when I talk about with respect to this person, n will be equals to mg, because there is no acceleration for this block with respect to this person, no? Both are at rest only, no? Yes or no? So this is one condition, but you have observed that whenever the bus is starting immediately or stops immediately, you will feel that you are going front or back, no? Yes or no? If someone is pushing you, no. If someone is pulling you there, no. But you are observing that you are feeling that some, like you are going front or you are going back, no? Like bus starts suddenly, you are going back. Bus starts, like stops suddenly means you will go front. Yes, no? So in that conditions, no one is stopping, no one is pulling you or pushing you. But there is a force acting. That force is called a pseudo force. Okay, that force is called as a pseudo force, that is false force. Let me take, there is a truck, okay, which is having a block, which is having a mass m. Okay, the truck is having mass m. This is going with acceleration at, acceleration of the truck at. There is another block which is a mass small m. Let me take that truck starts immediately and going with acceleration at. It will go back or not? Yes or no? If I start this immediately, it will go back. So which means there is some force acting on this block. That force is called as Completed? ఇక్కడ ఇచ్చే రిమోట్ ఇక్కడ ఇచ్చే ఏమైంది ఆన్ చేయాలా ఆఫ్ చేయాలా ఆన్ చేయాలా ఎవడు 3 మార్క్స్ వెళ్ళేది -3కి వెళ్ళింది ఓకే right on next topic friction so usually we'll take in terms of small f friction okay so f is directly proportional to the normal force okay normal force and to remove the proportionality we are adding constant called mu so what is the unit of mu here unit of mu like we have talked about the unit of spring constant no which is nothing but Newton per meter here there is no unit for mu because friction is a force and normal is a force so both for like SI units will get cancelled off so unit will be 0 there will be no unit for this okay no units for the coefficient of friction this one will called as coefficient of friction and n is nothing but the normal force so friction will be always acting in the opposite direction which is nothing but it's a opposing force we'll say friction is a opposing force and will always acts in the opposite direction so example if I talk here there is a block which is having mass m going with acceleration a okay going with acceleration a and this is a rough surface so rough surface means the friction will be there no so if it is going with acceleration a and I applied force here which is nothing but external force okay external force friction will be in opposite direction correct no if I apply force in this direction friction should oppose me no it is opposite direction so which is nothing but F external minus F will be equals to ma any doubt here any doubts here anyone I have applied a force on the object it is rough surface means it will try to oppose me no so friction will be in opposite direction or not acceleration will be in this direction no so F external minus friction should be equals to mass into acceleration correct no so this is how we will write the equation for the friction take down So note point, if external force is less than friction or external force is equals to friction, object will stay in rest. Object will stay in rest. So for example, a person who is standing here of mass or weight of 300 kg, okay, if I try to push him, will he go? No, right? Yes or no? So obviously external force, like whatever the force I am applying on the like the person, it is less or not? Yes or no? It will be less. So which means object, that the person will be in rest or no? Yes or no? Similarly, if I apply equal force also, it will be in rest only. But if I try to apply more force, if I try to bring the bulldozer and if I try to push him, no, he will go or not? So which means F external greater than F means object will be in motion. So three conditions are there. If external force is less than friction or equal to friction, object will stay in rest position. If it is more than friction, it will be in motion. Okay. Completed? Okay. There is 10 kg block. I have applied a force of 2 Newton. There is a coefficient of friction that is 0.2. Okay, 0.2. What happened? Who called? Okay, listen here. So 10 kg block, external force is 2 Newton and coefficient of friction is 0.2. Okay. So I can say that F is equals to mu n, no? Yes, no? F is equals to mu n. So what is n? It is mg, normal force, and this is mg. So mu I know that it is 0.2 and it is 10 and it is again 10. So which is like 20 Newton, right? 20 Newton or not? Any doubt here? Mu is 0.2, m is 10 and gravity is 10, which is nothing but 100 into 0.2 is 20. So is 20 is less than or greater than the external force? So I can say that Fs is greater than the external force, which means object is at rest or motion? Rest. 20 kg person is there, a baby coming and pushing means he will move or what? No, right? 0.2, like it's a given value, it's a given question. Okay. So there is a rough surface. This is vertical surface, okay? There is a block here and some person is pushing this block. Okay, some person is pushing the block with some external force. So object will try to, like this is mg. What about the friction force in the opposite direction? No. This is my friction force and this is my normal, no? In this case, how should I talk about the friction force? In the last case, I have taken about I have taken the horizontal condition. Now it's a vertical condition. So whatever the forces are there, no, F external should be equals to N and F should be equals to mg. What is the formula for friction force? Mu into N should be equals to mg. So mu into F external should be equals to mg. So mu will be equals to mg by F external. Any doubt here? So try to apply only the conditions. First we know the formula for the friction force, and whatever the forces are acting in the vertical direction, horizontal direction, I should consider, equate them and try to apply the formula. That's it. Okay. So first condition is horizontal, second condition is vertical. And one more thing, there is a block in between the two surface, both are rough surface. Okay. This is having a mass mg. How many friction force will be acting here? 2 friction force. One will be in here and another will be here. Correct, no? So can I say that 2F will be equals to mg? 2F will be equals to mg. There is 2 normal forces, N and N. Okay? 2 normal forces are there and 2 frictions are there and should be equals to mg. So 2 times of mu N will be equals to mg. Mu will be equals to mg by 2N. Total 3 conditions I have given for the friction here. Take it. So with this I will stop.